Yo, what up? Uh, all units, all semester, all second semester, our goal is to do the opposite of what we were doing in the first semester. The first semester, we took F and we found how F was changing. This semester, if I tell you how quickly something's changing, could you tell me what the original thing is? We'll find that it's harder to do. It's harder to go backwards. And the worst part about going backwards is sometimes you won't be able to. And we will have to really dive into what would happen if we can't go backwards and how can we handle that. So for today's lesson, we can go backwards every time. We can find what's called the antiderivative. Now I'm asking you to find big F. Right now, you don't understand what big F means. All you have to know is that it's the antiderivative of regular F. You're not sure what it's used for, how it's used. It does have use, but don't worry about it. Instead, it's just taking antiderivatives. And we talked about in class, the key to antiderivative power rule is to worry about the power first and then worry about the coefficient second. Like leave any other coefficients that you see out in front, leave it alone. Worry about the power first, then the coefficient, and then go ahead and combine the things. Students that make the most mistakes try to do it all at once. All at once can be done, it's just trickier. So instead, split it up, leave the constant, take the antiderivative, then multiply the coefficients. So I'm going to leave the 3, add 1 to the cube, multiply by the reciprocal, I realize I get a 3/4. I'm going to rewrite this as 1/2 x squared. I'm going to leave the 1/2, add 1, multiply by the reciprocal. Okay, and making sure that when you take the derivative, it makes sense. The 3 is going to come down, it gets x squared. Okay, that 3 and the 1/3 are going to cancel, leaving you just x squared times 1/2. That's x squared over 2, so you're good. So it's 1/6x cubed. X's antiderivative, there's a 1 here. A lot of people mess up on x squared, or on x, because they think it's 1. Then the antiderivative of 1 is x, and don't forget a plus c. You'll always need a plus c. It's a reason why going backwards is tricky. All right, let's do this one. I can't believe I put x squared over 2 again. It's a little bit sloppy of me. This is a new homework. I tried to put trickier examples than I did in the past for good reason. So you don't mess up on stuff like the 1/2. So that you don't mess up on stuff like the 4 and the 1/2 to give you 2. You can always double check. If you took the derivative of this, did you get this? Like you can do that in your head. The 6 comes down 3x to the 5th. The 3 comes down, that's 1/2 x squared. 2 comes down 4x. 2 is 2. Good. I'm going to rewrite all of this so that it has fractional powers. Don't forget that if you rewrite, you haven't done anything yet. You still have to take the antiderivative. Add 1, multiply by the reciprocal. Next step, combine. If you can do this all at once, hooray. Congrats. Most of y'all can't. We'll be able to potentially in the future, but for right now, just step it out. Leave the 4, take the antiderivative, add 1, multiply by the reciprocal. The 5/3 will come down. Boom, goes red, leaves the 4. Combine when we're taking the antiderivative. Don't forget your plus c. You're good. You need to remember, cosine's derivative is actually negative sine. And if the constant stays, I sneeze. Constant stays. right? Like 3 sines derivative is 3 cosine. Wait, hold on a second. 3 sines derivative is 3 cosine. Cosine's derivative is negative sine. 3 cosine's derivative is negative 3 sine. Oh, I don't want 3 cos, I want negative 3 cos. Sine's derivative is cosine. A lot of students going backwards, they get all mixed up, but just keep in mind what is a derivative. Okay. Denominator. Rewrite as negative exponents in the numerator. Leave the numbers where they are. They don't move. They are not being taken to the power. This is your first step. Don't make this mistake of moving the 2 up and say it's 2x to the negative third. Moving the 3 up with the x to the negative fourth. Don't make that mistake. Now let's 2-step it. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Now let's combine our coefficients and maybe rewrite it. Okay. Excuse me. Still feeling a little under the weather. All right. Same thing. Rewrite it so you can use the antiderivatives. Why did I put 3, 6? That's silly. I made this homework the day before we left for break. So my mind wasn't like 1000% in it. You know what I mean? Like I was done giving the midterms and grading the midterms, and I'm like, I still got some time. Maybe I'll change up the homework because I don't do any work over the break. No, wait, that's right. But then, you know, maybe I wasn't paying the most attention while I was doing it. Every single integral I give you. Oh, this is a short homework. This is great. Yeah, this is an easy homework. You will be able to take, which means every single question I ask you to take the antiderivative of, you will be able to. If I say evaluate the integral, this is the notation for taking the antiderivative, at least right now. Take the antiderivative. It means more than this, and it gets confusing. You can take this antiderivative, but not as you see it. You don't know any antiderivative product rules or quotient rules. We are going to learn different techniques to be able to go backwards, but you don't know them right now. So you will simplify. Now, I could have, for these questions, I could have just said, what is the integral of this? And it's the same. I don't want you to be confused and think that when you see an integral, you have to simplify. No, it's just like you're taking the antiderivative of whatever you have. I could have mixed up integrals in this one. Cool. Your answer is the antiderivative. That's it. Okay. You don't know the antiderivative chain rule yet, so you have to distribute. Then take the antiderivative. Most students, if they make mistakes, they distribute and then they just add a plus C. They're like, oh, I'm done. Like they have this plus C. Simplifying is not taking an antiderivative. Simplifying is allowing you to take an antiderivative. Like the one above us, we have to multiply. Now, how do you multiply? Well, if I asked you what's x squared plus, sorry, gosh, I'm getting tired. If I asked you what's x squared times x cubed, you know that it's x to the fifth. What did you do? You added those exponents together. Well, if I asked you what's x to the 1/2 times x squared, well, x squared is x to the 4/2. You get that this simplifies to be x to the 5/2. X to the first times x to the 1/2 is x to the 3/2. Sorry for the messiness. Add 1, multiply by the reciprocal. Leave the constant, add 1, multiply by the reciprocal. Worry about the constants now. Division, you don't know any division rules, but you do know how to simplify. X cubed divided by x and x squared divided by x. You can split this into two different fractions. X cubed over x, x squared over x. Well, that simplifies to be x squared plus x. Take the antiderivative. Exponent first, followed by the coefficient. All right. Some trig ones. Okay. Find f given f prime. Oh! The derivative of secant is secant tangent. So you just have to remember that. I'm not going to give you anything crazy that you don't think you're going to be able to do. 1 over sine squared. Oh, well, isn't that just cosecant squared? Isn't the reciprocal of sine cosecant? Oh, isn't the derivative of cotangent cosecant squared? Well, the derivative of cotangent is negative cosecant squared. So that means I need negative cotangent that has a derivative that's positive cosecant squared. All right, now we are solving differential equations. This is the steps of finding C, and either finding just the function f of x, the specific function, or finding the missing value that's asked for. So for these questions, we have this extra piece of information, and pay attention to what you're trying to find, whether it's a value or just f of x. You will take the antiderivative, and as long as you don't forget the key, which is making sure you have a plus c, you're gonna be all right. If you forgot the plus c, you're not going to get the right answer, because we want the specific function that has this location. This is helping us like figure out the original f that we want, that we're looking for. If f of -1 equals 6, we get c is equal to 5. And there you go. That's my specific f of x, whose derivative is 12x cubed plus 2. that has the point negative 1, 6. Okay, this is easy. Going backwards, I just get x cubed. I'm just two-stepping this out for all y'all. And I get x squared. Don't forget your plus c. F of 2 is 3. When you plug in 2 for x, you should get 3. C is negative 1. Therefore, that is your f of x. Now notice, the question is not find c. It's find f of x. So, make sure, guys, you write out the entire equation, f of x, with the c that is included. Too many students think that this question is finding c. Yes, you have to find c, but the answer you're looking for is f of x. Now, that's very important for the next ones where you're actually asked to find f of 3 or f of 2. You go backwards, and every time you go backwards, you need a plus c. So I get 2x minus 2x cubed plus c. I know f of 0 is negative 1, so c is negative 1. Now I have f of x, 2x minus 2x cubed minus 1. But the ultimate question that I'm trying to find is f of 3. 6 minus 3, 9, 27, 54 minus 1. It's 49. Okay. F must be negative 12. This is x squared times a half plus c. F must be negative 6x squared plus c. F of 1 is 4. Therefore, c has to equal 10. Therefore, f of x has to equal negative 6x squared plus 10. Now we need f of 2. Negative 24 plus 10, which is negative 14. What happens if I give you f double prime? Well, I'm asking you to find f of negative 1. Here, I'm asking you to find f of x. You got to work your way back from f double prime to f prime. But every time you go backwards, you need a plus c. You must realize that you have information to help you find the specific c's at the specific levels. Oh, this is very interesting. C is 0. So that means f prime is 2x plus 0, or just 2x. Which means then, when I go back to f, I'll have x squared plus c. I know f of, oh, this is supposed to be f. Jeez. Sorry. F of 1 is 2. My bad for this question. Hope y'all kind of figured out something was wrong with there. So, yeah. Yeah, it's just like if you have a second derivative, you need to work back one step at a time, and you need to use the information to find the c as you go backwards. Don't try to go all the way back to f, because every time you go backwards, you need a plus c. Cosine's derivative is negative sign, so that works out. f prime of 0 is 0 plus the cosine of 0, the adjacents, the horizontals, the x coordinates is 1. 1 plus c has to equal 2. That means c is equal to 1. So f prime is 4x plus cos x plus 1, which means f is going to be x squared times a half times 4. 4 times a half is 2, plus sine x's derivative is cos x, plus x plus c. F of 0 is 5. This is 0, this is 0, this is 0, this is c, this is 5. So that means f of x is 2x squared plus sine x plus 5. Cool. Yeah, this is a short video. All right, 2 more questions. Find a function f that has a horizontal tangent at 2, 1, and the second derivative of x is 2. Find f of 1. So here's the key. What does it mean to be a horizontal tangent? Well, you're thinking horizontal tangent means the slope of 0. You got to be able to do this yourself. I hope you're not just copying this down. That means the slope when x is 2 is 0. This is a point. You now have the information that you need to be able to go back to f of x and to be able to find f of 1. So you go backwards to f prime and you get 2x plus c. But you know f prime of 2 equals 0, c has to equal -4. So we now have f prime is equal to 2x minus 4. Now we go back another step to f. We get x squared minus 4x plus c. But we have the point 2, 1. F of 2 is 4 minus 8 plus c. That has to equal 1. C equals 5. This is -4 plus c at 4 is 5. F of x equals x squared minus 4x plus 5. F of 1 is 1 minus 4 plus 5, which is 2. Cool? All right. If you didn't get that, get this. Get it. Don't just copy this down. You have a point and you have a slope. Every time you go backwards, you need a plus c. Backwards even further. F of 3 equals 2. This c is 8. So that means my f of x function, specific that has all this information, is 2x squared minus 12x plus 8. This function has a horizontal tangent at the point 3, 2. The derivative is 4x plus 12, 4x minus 12. At 3, that slope is 0. If you plug in 3, you should get the point 2. 18 minus 36 plus 8. Whoa. Work up. It's not 24. Look at us. Look at us. It's 18. It's 2, right? So C is 20. Good 3, we should get 2. 18 minus 36 plus 20. $38 minus 36 is 2, good. And the derivative is 4x minus 12. Plugging in 3, you get 0, so you're good. This is your function, and you're trying to find f of 2. This is not better. 8 minus 24 plus 20, so that's negative 4. This is 4. All right, good start. Just make sure you know what you're doing. Let's not mess up on our quiz. This should be an easy first quiz. Stuff gets harder. It's a good little bring it back lesson. All right, peace.